Okay, there are a couple of things that are extremely important to us that we need to make sure we understand as we make sure that we master the work that pertains grade 7. There are certain worksheets we want to do is we use this material from the Department of Education for grade 7s to make sure that you are prepared even for national assessments, like your annual national assessment. This is part 3 of the worksheets. So from 65 to 144, you'll understand what worksheets we are speaking about here. Right. For example, as part of what you need to understand is the idea of what you call the numeric patterns. Some of them have what you call a constant difference. If one describes the patterns involving adding and subtraction, or addition and subtraction, shown in the number line, if one looks at the number line below, then one is able to see clearly that,
It's
for example, you have 20, 21, 22, 23. Okay, if you look at 22 through 21, you are able to realize that there is some addition of 2. Because if you add 20 plus 2, you get 22. You add 2, you get 24. You add 2, you get 26. If you subtract 4, subtracting 4 will produce a couple of things. Like if you subtract 4 in the red color, and you subtract 4 from 31, you get 27. You subtract 4, you get 31. You subtract 4, you get 35. And so on. So we have the following. Now I need to describe each pattern. So if you look at the addition of 5 in the green color, you start and move towards the right. 25, you add 5, get 30, and so on. So obviously here we're speaking of a what you call a constant difference, and this is shown in the number line. Now, if you had to describe each pattern like in the following example, if you have 44 and you add a number like 6 to 44, you get 50, and you add 6, you get 56. But if you have 44 and then you add a number like 9, or if you had 62 and you subtract 9 from 62, you get 53, and you subtract 9, you get a 44. So in other words, either you add or you subtract, you get what you call a constant difference because of the addition, also the subtraction part. We look at part A. If you have, for example, what is happening here? So let's do these exercises now, because this is what and how the grade 7s need to understand this. So you say adding 2, and then adding 2, you have 20, becomes 22, it becomes 24, it becomes 26. Then subtracting 4, right. If you're subtracting 4, you start from the biggest one. But if you're adding, you start from the smallest one. So we're going to use that idea here. Okay, there is 22, which becomes obviously a 25, which becomes a 28. So which means that you have adding, right here, adding. Okay, what has actually been added here? You can see that 3 has been added. So adding 3. If you're adding, you start from the smallest one, you start from 22, and then you have 25, and then you have 28. Okay, you're adding 3, because if you add 3 to 22, it becomes 25. You add 3, it becomes 28. So also here, if you look at the green color, you are actually moving from 30 to 35, then to 40. So it means you are adding, you're adding 5. If you're adding 5, you start from 30, and then it becomes 35, and then it becomes 40. Next, you start, now you are subtracting, because now you are moving in the opposite direction, from a big number to a small number. And then you write subtracting. And then you start from the biggest one. Right, so you're going to write subtracting here. Right, you start from 39, you subtract. What are you subtracting? How much are you subtracting? Okay, because from 39, then you are moving how many steps? 1, 2, 3, 4. It means that you're subtracting, obviously, you're subtracting 4. Right here. You're subtracting 4. So you have 39, then you have again 35, then you have again 31, then you have again 27, then you have again 23. Hey. So adding, okay, here you can see that you're moving from 35, 36, and so on. So you can see that there is an increase by just 1. This is just 1 step. So what are you adding? You are adding 1. In which case you have 35, then you have 36, then you have 37, you have 38, then you have 39. So you move now in the 4 direction, the blue color. So if you're moving to the right and the arrows are towards the right, because you start here, then the arrow is on the right. But here, the arrow now is on the left. So here you're adding now. Obviously here 36 becomes 42, and it's 1, 2, 3, 4, 5, 6 steps. So you're adding 6. But you're starting from 36. And then there's 36, which becomes 42. You're adding 6 to 42, it becomes 48. You're adding 6, it becomes 54. And this has a tendency to sort of continue in that manner. Continue in the given manner. Now let's look at the red part. The red part is you're subtracting. Right, so you're subtracting what?
5.
Well done, you're subtracting 5. Right, so if you are subtracting 5, what does it mean? So you start from the biggest one, which is 55. You subtract 5, you get 50. You subtract 5, you get 45. We stop at 45. Okay, this one is an exercise. What is happening with the green? Right, what is happening there? I mean, are we adding with the green or we subtracting? Are you able to see the green, this one here?
Yes, sir.
What do you think is happening there? Are we adding or are we subtracting there?
So we're adding.
We're adding, but yeah, but how much are we adding?
I 7.
Well done, we're adding 7. Adding 7, we're starting from the smallest one. We start from 101. then we have 108, then we have 115. Okay, we're adding. Then let's look at the blue. The blue, we're adding. What are we adding? The blue one, this one.
Is it wait blue?
Please come again.
Is it 6? I mean 5?
It is
Is
5.
it 5?
5. Adding 5, then we start from 102, then we have 107, then we have 1112, then we have 117. Then let's look at D. Okay, what do you think is happening with the green? In D.
We are adding.
Well done, we're adding.
Adding.
What are we adding?
Let's see. Are we adding 4?
Yes, we're adding 4. Well done, we're adding 4. So that we start with 19, then it becomes 23, then it becomes 27. Okay, now you look at the blue one. You're adding. What are we adding?
The blue one.
We're adding.
We're adding 1.
1. Well done. So adding 1 means to start from 26, then 27, then 28, then 29, then what? Then 30. Then we are subtracting. Right. So if we're subtracting, what are we subtracting? The red one.
Are we subtracting 3?
Yes, we're subtracting 3. Well done. So we start with the biggest one, which is 38. Then we have 35. In subtract 3, it becomes 32 and 29. Okay, what are we discussing here? We are discussing the idea of what we call the constant. Constant what? Constant difference. So in other words, this produces a constant difference when you subtract the same number throughout. Next question. Okay, there are a couple of other exercises. What do you think is happening with the green here in E before I move to something different?
So we are adding.
We're adding. What are we adding?
3.
Well done. We're adding 3. So if we're adding 3, then it becomes 63, 66, 69. What are we doing with the blue one? Adding what?
We are adding 8.
We are adding 8. So which is 63, we add 8, we get 71, you add 8, you get 79. Okay, then you are subtracting the red. Subtracting the red. How much are you subtracting in the red color?
So
to
4.
find how much you're subtracting, we count the number of steps. So we'd count 1, 2, 3, 4. And how many steps are those? They're actually a total of 4 steps. So how much are we subtracting?
So 4.
Well done, subtracting 4. So that we start with the biggest one, 79. It becomes 75. We subtract 4, it becomes 71. Next. Okay, is the constant difference we're talking about here. Okay, the last one is F. What do you think is happening with the green in F?
We are adding. We're adding 8.
What?
8.
We are adding 8. Well done. So if we're adding 8, then we start with the smallest one. What is the smallest one? It's 0. Then we add 8, it becomes 8.
0.
Add 8, it becomes 16. What about the blue one? What are we doing in case of the blue color? What are we adding there?
We're adding 12. I mean 6. We're adding 6.
We're adding 6. And then we're starting with 6. And if you add 6, it becomes 12. If you add 6, it becomes 18. The red color. What are we subtracting?
So 2.
We're subtracting 2. So subtracting 2, you will start with what? You'll start, for instance, with,
So the
yes. So we start with the biggest one, 21. You subtract 2, it becomes 19. You subtract 2, it becomes 17. Describe the rule for each pattern. Describe the rule for each pattern. So now here you have 27, 36, 45, 54, 63. The rule you describe is what is happening. So if you look at 27, that becomes 36, 9 is being added. 9 is being added. So at this point, you describe the rule. So the way you describe the rule is to say adding, you adding 9. You say adding 9. That is the rule. Let's come to A. What do you think the rule is in A?
so adding 8.
Please come again.
8.
Yes, we are adding 8. We are adding 8. So here we are actually adding 8. Right, so if we are adding 8, we have that. In B, what is the rule?
So we're adding 4.
Well done, we're adding 4. Okay, let's look at this one in C. What is the rule in C?
So adding, I mean, we are subtracting 3.
Well done. We are subtracting 3. Okay, in D,
So we are adding 5.
we are adding 5. Too easy. Adding 5 is the rule. Okay, let's look at E. What is happening in E?
So we are adding 4.
We are adding 4. Okay. Right here, the rule is we are adding 4. In F, what is the rule?
We're adding 5.
We are adding 5. That's right. In G, what is the rule?
So we are adding 9.
What are we adding again?
So is it 9?
In G?
Yes, sir.
Please think again.
Wait, we are adding 11.
Well done. Adding 11. H. What are we doing in H? The rule.
So we're adding 8.
Well done. We're adding 8. Right. In I, what are we adding? Or subtracting?
So 1.
Adding 1. In J, what are we doing?
So we are adding 2.
We are adding 2. Well done. Okay, so these are just number patterns. So if these are number patterns, we continue. We continue. Continue. The rule is adding 11, start your own pattern with 35. Okay, you can do that. Okay, there are certain numeric patterns that have a constant ratio. There are certain numeric patterns that have a constant ratio. So you can describe the pattern. There are certain numeric patterns that have a constant ratio. Like if you look at 2, 4, 8, 16. Okay, you start with the number 2, it becomes 4, it becomes 8, it becomes 16. Because you take the number 2, you multiply it by 2, it gives 4. You multiply it by 2, you get 8. You multiply it by 2, you get 16. So if you describe the pattern, you describe the pattern. Let's look at this one. So to describe the pattern here is you multiply the previous term by 4. So if you look at 8, it is now you have 8, 32, 128, 512. So you multiply 2 by 4 to get 8. Obviously, you are looking at this pattern here. So you multiply 2 by 4 to get 8, and then you multiply 8 by 4 to get 32. You multiply 32 by 4 to get 128. You multiply 128 by 4 to get 512. So, what is the rule? Multiply the previous term by 4. Multiply the previous term by 4. Next. What do you think the rule is in A? 2, 8, 32, 128, 512. What is the rule?
Says multiply by 4.
You multiply by 4. So we say, to describe the pattern, we say that multiply the previous term by what? By 4. Okay, if you look at 4, 12, 36, 108, 324, what do you think the pattern is? Describe the pattern.
So do you multiply by 3?
Well done, multiply by 3. So here we say you actually multiply by 3. So we say you multiply the previous term by 3. In C, what do you think is happening?
So multiply by 2.
Well done. Multiply the previous term by 2. Multiply the previous term by 2. Okay, so okay, these are way too easy. Let's just do D. And then I'm going to give you homework on the others, and then we move on to the next section. What do you think is happening in D?
So I'm multiplying by 6.
Okay, you can multiply by 5. Multiply the previous term by what? By 5. So
5.
it's 40. By 5 is 200. By 5 is this. By 5 is that. Okay, in E, what do you think is happening?
So you multiply by 6.
Yes, well done. So multiply the previous term by 6. Okay, there are certain things that are called numeric patterns. Neither a constant difference nor a constant ratio. There are some of these patterns, like in unit 67. What is the difference between constant difference and ratio? The constant difference, for example, we saw that if you have 21 to 23, you can see that you are adding 2. And here we have the constant ratio. And we can see that 2 now you keep multiplying by 2 throughout. So if we say here now, describe the pattern 1, 2, 4, 7, 11, 16. What will the next 3 terms be? You're applying the identified rule. This pattern has neither a constant difference nor a constant ratio. It can be described as increasing the difference between consecutive terms by 1 each time, or adding more than was added to get the previous term. Describe the pattern and draw a number line to show each. Term 3, describe the pattern and draw a number line to show. Okay, for instance, if you look at this one, this pattern has neither a constant difference nor a constant ratio. It can be described as increasing the difference between consecutive terms by 1 each time, or adding 1 more than was added to get the previous term. Let's look at the kinds of patterns that are different. Let not have a constant difference or a constant ratio, like this one. If you are to describe the pattern and draw a number line to show each, what is it here? Because now 2, 4, then there's 8, there's 14, there's 22. Right. What is happening here? How do we describe this pattern? Because there is 2, then there is 4, then there is 8, then there is 14, then there is 22. What do you think the pattern is in? Okay. Yeah. This one, 2, 4, 8, 11, 22. What do you think the pattern is there?
Is it a constant difference?
Okay. What do you think the constant difference is?
When you just
What are we adding? In other words,
when
are we
you're adding
adding
a
a
number,
fixed number in
a
this
specific
one
number.
here? 2, 4, 8, 14, 22. What difference are we adding, if anything?
So we're not adding anything.
Right. So, but there's an increase because 2 becomes 4, and then 8, it becomes 14, 22. There's an increase, but how do we describe it? Okay, so it's tricky. Here it is. It is described as increasing the difference between consecutive terms by 1 each time. So it's increasing. The difference between consecutive terms by 2 each time. Okay, increasing by 2 each time. Because if you add 2, you get 2 plus 2. So here you increase, you add 2 here. And then now you increase by 2, you add 4. Here you add 6. So you just increase by 2. In here, increase by 2, you add what? You add 8. Like that. Okay, what do you think is happening in A? What pattern is there in A? Because I am able to see A.
Is it constant? Yes, sir.
Uh-huh.
Is it constant ratio?
Okay, it looks like it's a constant ratio. Obviously, there's a constant difference because here we are adding 2, and then here we are adding what?
We
We're
add
adding 4,
4.
and then here you're adding 6, and then here you're adding 8. Because 20
We
plus
add
8 is 28.
6.
So it's
8.
increasing the difference between consecutive terms by 2 each time. Increasing the difference
Difference
between consecutive terms by 2 each time. Next, what do you think is happening in B?
So is it a constant is it
Okay, take your time. Are you able to see part B that I'm talking about? This one here.
yes, sir.
Right. Yeah. Describe the pattern there.
Is it a constant ratio?
Okay. Is it a constant ratio? Let's check. Because you can see that now here is 3 subtracted. Okay. And then here 6 is subtracted. 9 is subtracted. 12 is subtracted. Okay, it's sort of decreasing. Would call these decreasing the difference between consecutive terms by 3. By 3 each time. So we continue. What about C?
C is a constant ratio.
Okay, let's check. Okay, what is the
Okay,
difference?
what is the
What
difference?
is the difference between 3 and 6? Okay, what is the difference between 3 and 6? What has happened? 3 and 6. 3 has increased by what?
It's 3.
By 3. Now it has increased by what?
It's been increased by 4.
By 4. So here 3 was added. 4 was added. 5 was added. 6 was added. So we're increasing. So because the 6 is bigger than the 3, so it is increasing the difference between consecutive terms by okay. Increasing the difference between the consecutive terms by 1 each time. By 1 each time. Okay, because it is 3, then it is 4, it is 5, it is 6. So it's by 1 each time. Okay, let's come to this one. What do you think is happening in D?
So it's a constant difference.
Please come again.
A constant difference.
Okay. What is happening? Are we increasing or are we decreasing?
Decreasing.
We are decreasing. By what each time?
By 2.
Decreasing by?
2.
Here is -1. Here is -2. Here is -3. And here it's -4. So decreasing. The difference between consecutive terms by 1 each time. So you're just decreasing by 1 each what? Each time, because but decreasing by 1, then it's -2, then it's -3, and so on and so forth. Next, what do you think the next one is? What is happening here in E? What do you think?
So a constant,
Let's come again.
constant ratio. A constant ratio.
Okay, let's check. Okay, what is the difference between 6 and 7?
It's
What has
1.
happened? No, there's 6 and then 7. What has happened?
It's +1.
1. And then between 7 and 9, what has happened?
+2.
And then between 9 and 12, what has happened?
+3.
Yeah, and that is the idea. So in other words, here it's +1. Here is +2. Here is plus what? 3. Here is plus what? Oh, that is increasing. Increasing
4.
by 1 each time. What about F? What is happening in F?
It's a constant.
What do you think in F again, please?
Is it a constant difference?
What is happening between 1 and 3?
+2.
Increase by 2. Between 3 and 7?
+4.
By 4. 7 and 15?
+18. I mean 8.
Right, so obviously at this point you increase by what here? By 2. You increase by 2. Here you increase by what? 4. Here by what? By 8. Here by what?
By 15. I mean
By 16.
16. 15.
Please come again.
16. Yeah. 16.
Yes. So now what is happening here? So you can see that you're increasing.
Increasing.
Increasing by how much each time?
By increasing by
Increasing by
is increasing by. Oh, is it? Can we say multiplying by?
Okay, yeah. So you are actually adding. So you are increasing by what? By multiplying. Or you are increasing by. You can just say you are increasing by adding. The previous difference. The previous difference. You are increasing by adding the previous difference times 2. The previous difference times 2. The previous difference, the difference was 2 multiplied by 2. The difference was 4 multiplied by 2. The difference was 8 multiplied by 2. You are increasing by adding the previous difference times what? Times 2, isn't it?
Is
Okay, G. What is happening in G? What is happening
so
in G?
we are decreasing by 5.
Okay, between 13 and 9 is a decrease by what?
5. I mean 4.
Yeah, between 13 and 9 is a decrease by 4. Okay, between 9 and 4 is a decrease by what?
5.
Okay, so in other words, here, 4 was subtracted. 5 was subtracted. 6 was subtracted. 7 was subtracted. So we are decreasing. Decreasing by adding. So by subtracting, okay, what do you think is happening? How do you describe G?
So we are decreasing by as in 1.
Yes. Like we said here, increasing the difference between consecutive terms by 1 each time. So here you are decreasing the difference between consecutive terms by 1 each time. Decreasing the difference between consecutive terms by 1 each time. Okay, H, what do you think is happening in H?
So we are increasing by 1. It's then 5, 6, 7.
Please come again.
So are we increasing by 1?
Okay, between 9 and 14, what happened?
Increase by 5.
Between 14 and 20,
Increase by 6.
so what is happening? Increase by what?
Is it a
You are increasing the
constant?
difference. You are increasing the what?
The
You're
difference?
increasing the difference between consecutive terms by 1 each time. Okay, what about I? What's happening in I?
So we are decreasing the difference between consecutive terms by 1.
Okay, what is the difference between 24 and 18?
So 6.
Okay, so here we subtracted 6 here. Yeah,
5.
yeah.
So
Okay, so what is happening here? Because it's minus 6, minus 5, minus 4, minus 3. What is happening here?
So we are decreasing the difference between consecutive terms by 1 each time.
Okay, so obviously this is actually an increase because it's minus 6, minus 5, minus 3 is bigger. So it's an increase. So we are increasing the difference between consecutive terms by One each time. Next. Okay, what about between 19 and 20?
So we are
Please come again. Oops. What is happening in J?
so we are increasing the difference between consecutive terms by one each time.
Okay, let's just check. What is the difference between 19 and 20?
One,
And then here,
two,
here,
three,
and here. So it's an increase, right?
four.
Good.
Yes,
We're
sir.
increasing the difference. We're increasing the difference between consecutive terms by one each time. Next. Okay, there are certain things, there are the things that pertain what we call the numeric patterns. The what? The numeric patterns, okay? And the numeric patterns now, they involve the tables. So they involve tables. So let's see what we can do. Let's see what we can do. Okay, tables like this. Let's look at this. Give a rule to describe the relationship between the numbers in this sequence. Like if you look at 2, 4, 6, 8, use the rule to find the value of the 10th term. Okay, like at this point, 1 becomes 2. The position in the sequence. The position is position 1. The value of the term is 2. The position is 2. The value is 4. The position is 3. The value is 6. The position is 4. The value is 8. The position is 10. What is the value? What do you think? Please come again.
So is the position 10? I mean, is it 20?
Yeah, in other words, what should be in the question mark? Are you able to see this question mark here?
Yes, sir.
Yeah, are you able to see it? Yes. No.
Yes, sir.
Okay,
Is
thank
it
you. What do you think what number must be in the place of the question mark?
20?
Please come again.
20.
20. Well done. So there must be 20 here. Why? Because you can see if there's 1, then it's 2. It doubles. And then if there's 2, then it becomes 2 times 2, which is 4. If there's 3, then it becomes 6, which means 3 was multiplied by 2. 4 becomes 8 multiplied by 2. 10 becomes 20 multiplied by 2. So you have 1, 2, 3, 4, 10. And then what happened? Now this became 3, which became like 1 by 3. It became 2 became 6, which means 2 was multiplied by 3. Multiply 3 by 3, you get 9. You multiply 4 by 3, you get 12. You multiply 10 by 3, you get 30. Next. Okay, let's look at A. What should be here? Because 1 became 4, 2 became 8. This one became 12. This became 16. And now there's nothing here. We need to fill in. Okay. What happened? 1 became 4. It's what? What must be here?
Um, 1 times
Because here it
4.
was 1 times 3, then 2 times 3, then 3 times 3, then 4 times 3. And then here it must be what? So here you can see that you start first, always you start with what? You start with the position. Because it's 1, 2, 3, 4, the position. So the position is 1. And then it was multiplied by what? It was multiplied by 4. Here the position is 2. It was multiplied by 4 to give 8, because 2 times 4 is 8. Here the position is 3. It was multiplied by what?
So multiplied by 4.
It was multiplied by 4. Well done. Here the position is 4. It was multiplied by what?
So 4.
4 again. So you're just multiplying by 4 throughout. Okay, let's come here. Then what must be here and what must be there? Because this is position 10. You start with the position. Then it must be multiplied with what here?
So 10.
But you are multiplying by 4, by 4, by 4, by 4. So it can't change.
So
Just the position times 4, the position times 4, the position times 4, the position times 4, the position times 4. So what must be here now? Here. Because here is 4 times 1, which is there. 2 times 4 is 8, which is there. 3 times 4 is 12, which is there. 4 times 4 is 16. So this 10 times 4 is what?
it's
40.
40.
Yeah, which is there. Okay, let's come to in B. What must be here? First you start with the position, right? So the position
Sure.
is 1 times what? 8. Here the position is 2
8.
times what?
8.
8. Here the position is what? The position is this one. Because you can see it's the word position. So here the position is 3 times what?
8.
Times 8. Here the position is 4 times what?
8.
So what must be here now? Here. What is the position here? What is the position here?
Yeah.
The position is 10 times what?
10. 8.
Times 8, because it's times 8 throughout. It's times 8 times 8 times 8. So it will be times 8. And then now here 10 times 4 became 40, which was there. Like 4 times 4 is 16, which is there. 3 times 4 is 12, which is there. 2 times 4 is 8, which is there. 10 times 8 is what?
10 times 8 is 80.
It's 80. 80. Next, let's come to part C. What must be here?
So 1 times 12.
Yes, it must be the position. Times 12, which is 12. The position is 2 times what?
2 times
Because
24.
times 12, because 2 times 12 is 24, isn't it? Then the position is 3 times what? To get 36. To get 36 times what? 3 times what? That gives 36. It's 3 times 12,
36.
isn't it? Okay. Also now the position is 4. Is 4 times what? That gives 48. The position is 10 times what? It's times 12 times 12 times 12. So it must be 12. What is 10 times 12?
So 120.
120. Okay, what must be here?
So 1 times 7.
1 by 7 is the position times the number that is actually associated with that. So here the position is 2 times what to give 14?
7.
Here the position. The position is 3 times what to give 21?
7.
Here the position is 4 times what to give 28?
7.
Here the position is 10 times what?
It's 7.
10 times 7 because it's times 7 times 7 times 7. So it's times 7. What is 10 times 7?
70.
Okay, let's look at E. You have 1 position. Times what to get 5?
5.
Position is 2. Times what to get 10?
5.
Here the position is 3. Times what to get 15?
5.
Here the position is 4. Times what to get 20?
5.
Okay, so what must be here? What is the position here? The position is what is on top here. 1, 2. Here they just, this one is great because they jumped the position because 1, 2, 3, 4. There was supposed to be 5, 6, 7, 8, 9, 10, but they jumped. That is why this one is grayed out. They jumped. So what is the position? The position was 4, 3, 2. What is the position here?
So is it 10 times 5?
Times 5. Well done. What is 10 times 5?
50.
Okay, now we need to complete the following tables in the same manner. Okay, because this thing of completing the tables is extremely important when one is learning. Okay, like in this example, 5, 10, 15, 20. Position of term times 5. Position of term times what? Times 5. So position 1 times 5. Okay, position of term times 5. Position of term times 5 gives you this. Position of term is 2 times 5 is 10. Position of term is 3 times 5 is 15. Position of term is 4 times 5 is 4 times 5 is 20. Position of term is 15 times 5. 15 times 5 is 75 anyway. Okay, let's come to this. Position of term is what here? Is 1 times 10
Is 1.
yes. Position
10.
of term is 1 times 10 is 10. Position of term is 2. What is 2 times 10?
20.
Position of term is 3 times 10. Position of term is 4 times 10. What is 10 times 4 is 40. Position of term is 20. Position of term is what? Is 20, but we're multiplying by 10. So, in other words, we say here, we write the following. Here we're going to write 10, 20, 30, 40. And then we write like this. Position of term times what? Is position of term times
10
10.
times
Like
10.
1 times 10, 2 times 10, 3 times 10. Because 3 times 10 is 30. 4 times 10. So it's position of term times 10. Okay. Position of term is 20. Then what must be here? What number must be here?
1,000. I mean, no, is it 2,000?
How did you get that?
So
You say position of
10
term times 10. Position of the term. So it's 20. Position of the term is 20 times 10. Position of the term is 20. Like here, it became position of the term times 10, which is 40. Position of the term times 10, which is 30. Position of the term times 10, which is 20. Position of the term times 10, which is 10. Position of the term is 20 times 10. What is 20 times 10? 200.
2000. I mean
200,
200.
right?
Yes, sir.
Okay, now let's come to this one. Here is position of the term times what here? Like position of the term times what? Like it's 1 times what to get 3?
3.
So in other words, at this point, what? Yes, times 3. So in other words, it is position of the term times 3. Like this one times 3. This one times 3. This one times 3. This one times 3. So here is position of the term times what? So position of the term is 28 times 3. What is 28 times 3?
28 times 3.
Yeah?
Um,
What is
84.
28 times 3? Because according to the
80,
rule we are using, we are saying position of the term times what? Times 5. So what is 28 times 3?
84.
84. Well done. Next. Okay, here is position of the term times something. What must be here? Because it's empty. There's a blank here. But something must be there. We must fill this in. What must be there? Because here is position
So
of the term times something. Position of the term times this. So position of the term times what? Times 8. Position of the term is so here it's position of the term times 8. Position of the term times 8. Position of the term times 8 is 16. Position of the term times 8 is 24. Position of the term 4 times 8 is 32. So position of the term times 8. This is times 8 everything. So here is times 8 to give 150. What number do you multiply by 8? Because this you multiply 4 by 8 to get 32. So you must multiply certain number here by 8 to get 150. What is that number? Because here you multiply the number 2 by 8 to get 16. You multiply the number 1 by 8 to get 8. You multiply the number 3 by 8 to obtain 24. And then you multiply 4 by 8 to get 32. What number do you multiply by 8 to get 150?
so is it 15?
Uh-huh. So this one is tricky. So there is a number, you can call the number x. So there's a certain number x. You multiply by 8 to get 150, which means x is 150 divided by 8. What is 150 divided by 8? What do you
Is
think?
it
150 divided by 8, what's the answer?
18? 17 or 18?
All right. Uh-huh. What is the answer?
So is it 18?
Okay, we're checking that one now. So obviously you need to think a little bit here. Okay, so it is 150 divided by 8. Okay, if you divide 150 by 2, what you get?
So you get 75.
75. Divide 8 by 2, what you get? You get
So
4.
you get 4.
So that would be the answer. So 150 divided by 8. Which is 75 out of 4. To check these, then you take 75 out of 4, you multiply by 8. 4 goes how many times into 8? 2 times. What is 2 times 75? 150. So that must be exactly that. Okay. But obviously, what kind of a position is this? Because but that is the sort of position you need to get. And these can also be written as, if you use a calculator, 18.75. 18.75. Next, what must be here? Because 1 was multiplied by what? By 12. Position times this position of term by 12. By 12, by 12, by 12, by 12. Okay, if you multiply this one by 12, what do you get?
12
Okay,
by
multiply
4.
1 by 12, you get that. By 12, you get 24. By 12, by 12. Okay, multiply 100 by 12, what do you get?
120.
Well done, 120. Hey, let's look at a little bit more. We are finishing this off. We're just looking at the number patterns here. Okay, now the position is 1. You multiply by what? By 15. So is position of term times what? Times 15. Multiply 1 by 15, you get 15. Multiply by 15, you get what? 30. Multiply by 15, you get 45. Multiply by 15, you get 60. So what is it that you can multiply by 15 to get 280? So you can say 15 times x gives 280. And then x is 280 out of 15. What is 280 out of 15?
280 out of 15 or
What do you think?
so is it 280 divided by 15?
Yes, it is 280 divided by 15.
So is it 18?
It's approximately
If
18.
I'm correct.
So you can divide 280 by, so you can divide 15 by 5. You divide 15 by 5, what do you get? You get 3. You
Yeah.
divide 280 by 5, you get what? 56.
6.
You get the point?
Yes, sir.
So if you then say you divide 15 by 5, you get 3. You divide 280 by 5, you get 56. So that's the answer. It must be like 56 out of 3. And 56 out of 3 is equal to what? You can write it as a mixed fraction, which is exactly 18 and 2/3, which is 18 points that. 18.67. Next, let's look at this one. So you multiply 1 by 1 by what? You multiply this by that. You multiply this by that. You multiply this by that. Okay. Okay. So position of term times position of term times times what? Okay, position of term times what?
Of by position in terms of term times 4
Please come again.
by is
By
1.
position squared. By position squared, because now here it's 1 times 1 squared. Here it's 2 times 2 squared. What is 2 squared? It's 4. 4 times 2 is
It's
what? 8. So this one is position of term times 3 squared. What is 3 squared? Is 9. 9 times 3 is 27. Position of term is 4. And 4 squared. What is 4 squared? It's 16 by 4, 64.
it's
So
60.
here, 1, 2, 3, 4. And then here now, you get to, okay, it's 1, 2, 3, 3, 4, 4. So here, what's going to happen here? This one is 50. So what is the value of the term? So it's position of the term. So this is position 4. So this one is going to be position what? 50. So in other words, it's going to be position 50 times 50 squared. It's just the same. 3, 3, that's squared. 2, 2 squared. 1, 1 squared. 4, 4 squared. 50, 50 squared, right? And then now, 50, 50 squared is going to be 50 times 50 times 50, which, what is the answer? Okay, you can write it. That one is very long, but it's a
50
um.
times. Is
Please
it
come again.
2? Is it, is it 2,500?
Okay, it's long. It has 3 zeros. 100 and what?
Is it 125,000?
Yes, 125,000. Thank you. Next, there are number sequences that need to be mixed with words. So it's very important that when you study number sequences, they can be mixed with words, like we can see here. And we did something like this, but I want us to sort of reinforce this and make sure you sort of understand this. Look at this pattern. What will the 20th term be? Okay, let's look at this pattern, for example. This pattern is 4, 7, 10, 13. What is the first term of this pattern? What is the first term of this pattern?
So, isn't it 4?
You're saying what?
4?
Yes, the first term of this pattern is 4. Then you say the first term, so you always say the first term, then the second term, then the third term, and the fourth term. Then the number in the brackets corresponds to with the position of the term in the sequence. Okay, so let's start with this one. The first term is 4. But now, you can see therefore that the number in the brackets corresponds with the position of the term. So now this is position 1. So you put 1 in brackets. Then you fill in the other blanks. So which becomes 3 times 1 plus that. But obviously you take into account the sort of the pattern that is happening, because by how much is this one increasing this? Plus 3, right?
Yes, sir.
Plus 3. So you take the first term and then you take the next term. And then you take the other term. Three. Okay, you take the other term, 10. 3 into 3 plus 1. What will the 20th term be? Next. Okay, let's look at the next one. What did the 20th term be? What do you think the 20th term is going to be? Here. Because the fourth term is this. What do you think term number 20 is going to be? What do you think?
Is it going to be 64?
Right, because term number 20, okay, because the fourth term is this. So term number 20, it's going to be what? So it's going to be 3 into, because the fourth term is 3 into 4. So the 20th term is going to be 3 into that plus 1. And what is the answer? It's going to be 61.
61.
Okay. Next. Look at the following sequences, for example. Describe the rule in your own words. Calculate the 20th term using a number sequence, like the number sequence 5, 7, 9, 11. Rule in words 2 times the position of the term plus 3. 20th term is 2 times 20 plus 3 is 43. The number sequence 2, 7, 12, that. What is the rule? Okay, look at this. The rule in words is 2 times the position of the term plus 3. That becomes the rule in words. And then you come and write the 20th term, which is 2 times 20 plus 3, which becomes 43, for example. Okay. Here, what is the rule here? By how much is this thing increasing this? 2, 7, 12, 17. By how much is it increasing?
Is it by increasing by 5?
Yeah, it increases by 5. It increases by 5. The rule in words is what?
Is it plus 5?
Because it increases by 5, then what you do is you put 5 like this. Then you would say like the first term. What would the first term be? So it becomes 5 into the position of the term. So because of that, you can say, like here, we're like 3 times the position, like fourth term is 4. So you can write here and say 5 into the position of the term plus what? Okay. So what are we adding? Like if it's the first position, position 1, the first term is 5 into the position of the term. Okay, 5 times 1, then it must be 2. It means you must subtract 3 from it. Okay, 5 times 2. What is 5 times 2?
10.
Minus 3.
7.
So the rule in words must be 5 times the position of the term minus 3. Here. 5 times the position of the term minus what? Minus 3. Because what is 5 times 3 for term number 3? 5 times 3.
15.
Minus 3.
It's 12.
What is the rule in B? By how much is this one increasing or decreasing this? By how much is it increasing or decreasing that one in B?
It's increasing by 2.
What are we doing there to get -6 from -8? What has happened? Did we add or did you subtract? What did you add or what did you subtract?
We added -2.
We actually added +2. Because 2 minus 8 is -6. +2 is -4. +2 is -2. Okay, so here you then say it is, we are just like adding 2. So in other words, it is 2 times, because you're adding 2 is 2 times the position. Then you must add or subtract something. Let's look at 2 times 1. What is 2 times 1?
2.
2. Then you're subtracting what here? To get -8.
2 times. We subtract 3.
Okay. So if you're not sure, just say 2 minus x. 2 minus something must give us -8. And then you solve for x. 2 minus something. We must subtract something here to get -8. So which means you can have the 2, then you bring this one to the other side. So the 8 becomes plus and the x becomes plus, and it means that the x is what? Is 10. So it means you are subtracting 10 because 2 minus 10 is minus what? Is -8. Okay, let's look at position 2. Term number 2, what is 2 times 2?
4.
4 minus 10
It's 6.
is -6.
Minus
3. 2 times 3 for position 3. For term 3, what is 2 times 3?
6.
6 minus 10?
6 minus 10 is -4. I mean,
-4.
yeah.
Well done. Okay, let's come to this one. What is the rule in C?
Is it adding 3?
Okay, well done. Well done. Here we are adding 3. We are adding 3. We are adding 3. Okay, since we're adding 3, you say 3 times the position. Then to get this one, you want to get -1. What are you supposed to subtract here? 3 minus what to get -1?
3
It's 3 minus 4.
minus 4.
3 minus 4 is -1, isn't it? Okay, let's check if this is correct. If you look at position 2, what is 3 times 2?
6.
6 minus 4. 3 times 5.
15.
Minus 4.
Either 11.
Okay. Anyway, this is term number 3. Term 3 meaning position 3. So 3 times 3 is what?
It's 9.
9 minus 4.
5.
Okay, let's look at this one. What's happening in D? What is the rule in D? Okay, obviously we're not finishing this. We can finish them off. Okay. What is the 12th term? What would the 12th term be here? Term number 12. 12th term or 12th term. What would it be? In C.
Would be
So it's 3 times 12 minus 4. What is 3 times 12?
Is it 20? 32?
32, well done. What is the 15th term here in B? 15th term, you put 15 in the place of the position. So what is 2 times 15 minus 10? What would 2 times 15 be?
It's 30.
30 minus 10, so that is going to be 2 times 15. And 2 times 15 is 30. 30 minus 10 is what?
30 minus 10. 20.
Okay. Here you're adding 3. Okay, the rule is 3 times the position. Because we're adding 3. 3 times the position. Then what can we add or subtract to get 6 from 3?
3.
It's only 3. We can add 3. Okay, let's check if this is correct. Let's get term number 2. Position 2 would be 3 times 2. What is 3 times 2?
3 times 2, 6.
Plus 3.
9.
Okay, the 12th term. What is the 12th term? What is 3 times 12? 19th. 19th.
Two.
19th. So 19th term is what they want. What is 3 times 19 plus 3? What is the answer?
So 3 times 19 plus 3?
Yes. What's the answer? 60. Okay, that's fine. Okay, E. What is the rule? And what is the 18th term? What is the rule in E? What do you think?
So you add 4.
You add 4. Well done. Plus 4. Plus 4. Plus 4. So what is the rule in the E part? So the rule, you always take the number you're adding, you multiply by the position. And then what you add or subtract to get minus 6 here? There's something you must add or subtract to get minus 6 the first term. What is it? You get the question. Something you must add or subtract from 4.
Don't we subtract 4?
Subtract 10. Because 4 minus 10 is minus 6. Let's check if we get term position 2. Term position 2, what is 4 times 2? For term position 2.
It's 8.
What is 8 minus 10?
Negative 2.
Right. So what is the 18th term? 18th term is going to be 4 by 8 minus 10. What is 4 by 18 for the 18th term?
72.
Okay. 4 by 18 is 72. Very well done. Minus 10 is what?
62.
Good. So this is exactly 72 minus 10, which is what? 62. Let's look at this one. Position. Now, here, what are we adding here?
So we're adding 5.
So it is 5 times the position. What is the position? 5 times the position. Then to get 7, what do we add to 5 to get 7?
2.
Well done, 2. Then what is the 12th term? The 12th term is going to be these times 5 times 12 plus 2. What is 5 times 12?
It's 60.
62. Okay, in G, are you able to see G?
Yes, sir.
What is the rule in G? First and foremost,
Says
what are we adding or subtracting here in G?
are we adding 2?
Are we adding 2? That's the question. Because 2 becomes 5. But what about then we have 3? What are we adding actually in G?
Aren't we
What are we adding in G? Okay, obviously you need to experiment. You need to write some steps, isn't it? And then say here we're adding 3, isn't it? And then here, what are we adding here? Is minus 2.
so
We're
it's
subtracting
2.
2 here. And then here, what are we subtracting here? It's just 0. There's no change here. And then here, we are adding 2. And then here, we are subtracting 1. Like this. So what is the rule? And therefore, what is the 21st term? Okay, you're going to think about that one. Let's look at H. What are we adding here? Here, what are we adding?
2, sir.
2. Here, what are we adding? Here, what are we adding?
Sorry, 2.
Yeah.
2 all the way.
Here, what are we adding? 2. So what is the
This
rule here in H? In H, what is the rule?
plus 2.
So it is 2 times the position. 2 times the position. Minus what? Minus what or plus what? To get minus 3. Minus 5. Okay. Now let's check position 2. If you put 2, what is 2 times 2 here?
It's 4.
Minus 5.
It's 1.
It's getting minus 1. So we're getting the correct one. So now, what is the 15th term here in H? What is the 15th term?
So is it 15?
Okay, let's check. So 15th term is going to be, you put 15 here. Minus 5. What is 2 times 15? It is 30 minus 5. 30 minus 5 is what?
30 is for 25.
It's 25. Okay, I'm going to leave this one is your homework. This is your what? It's your home activity. I'm going to check this one in our next meeting.
Homework?
You need to finish it. You need to find the rule and the 21st term. Let's do I. What is happening in I?
So we are adding 4.
So we are adding 4. What is the rule? Is 4 times the position? Then to get 3, what do we add? What do we do to 4? Position 1. Position 1, it means that we are taking the position to be 1. So 4 times 1, we're just dealing with 4. How can you make 4, 3? What do we add or subtract?
You subtract 1.
So what is the 14th term here? What is 4 by 14? It's 56 minus 1. What is 56 minus 1?
55.
Okay, let's look at the rule in J. What is happening in J?
So
In
yeah,
J, we're adding 10, right?
Yes, sir.
So what is the rule? It's 10 times the position. To get 4, you can add what? To get 14, it's 10 plus 4. It gives 14. What is the second term? Let's check the second term. Second term in the position, place, you put 2. 10 times 2 is 20, plus 4 is 24. What is the 25th term?
So is it 250?
250. That's what it is. Is 10 times 25 is 250 plus 4. What is 250 plus 4?
254.
Next. Okay, there are certain patterns which you call the geometric patterns. So the geometric patterns have a tendency to sort of trace a geometric formation. So they have a tendency to trace a geometric shape, like the one that you can see on the picture. It looks like it has a given shape. What do we call a shape in mathematics that has 1, 2, 1, 2, 3, 4, 5, 6? What do you call a shape that has 6 vertices? What do you call this shape?
A
6 corners. What
hexagon.
do you call it?
A hexagon.
Yes, it is called a hexagon with 6 shapes, 6 vertices. It's called a hexagon because hex means 6. Okay, now let's continue. Create the first 3 terms of the following patterns with matchsticks and then draw the patterns in your book, complete the tables. The triangular pattern. A triangular pattern, but you need to first create the first 3 terms of the following pattern with matchsticks and then draw the patterns in the book. You need to complete this. So obviously at this point you would have the triangular pattern, position of a triangle in the pattern, position 1, position 2, position 3, position 4, position 5, position 6, position 7. So what is the position of a term in a pattern? Position 1. Okay. Okay, yeah. What is the number of matches in position 1? Because now we're looking at the position of a triangle in the pattern. Look at the triangular pattern. The number of matches in position 1 in a triangle. So you need to think about this because it's going to come in the exam. It's going to come in the exam. So what must be here? What is the number of matches in position 1?
The number of matches.
Yes. The number of matches
how many
in position 1.
how many matches
Please
are
come
there?
again.
I didn't. How many matches are there, sir? I didn't
Yes, how many matches are there?
really.
All right, so here we will take a match here. A match here and a match here. So the matches in position of a triangle 1, how many are they? There are only 3. Because we're speaking about the triangular pattern. What about in 2? How many matches are there? Okay, so you start, you have this one, and then you have this one, and then you have this one. Then you continue. You form another triangle here. So the other triangle is going to have a match here. And it's also going to have a match here. So how many matches are there?
5.
There are 5. What is going to be, what will the next one be?
7.
Okay, that's very well done. Because now you're going to just complete first. You draw this one as it is. And then you do this. And then you do that. And then you do this. And then you do that. Okay. And then you do this. And then you do that. So let's count the matches here. There are 7. How many will there be here?
9.
Here,
11.
here,
13.
here.
15.
Okay, let's look at the square pattern. Number of matches in the square pattern. How many matches are going to be there in the square pattern?
So 4.
They're going to be 4 first. Because now you're going to have. You're going to be 4 first. Because now you're going. Something just happened. Okay. All right, that's fine. Just forgive me. There was just my pen got placed and it started writing everywhere. So, but they're going to be 4. And then here, next one, because now you're going to have this one, tail to head, tail to head, tail to head, tail to head. Then next, what's going to be there? How many are going to be there next? There, Lindsay?
So 7.
Yes, well done. Because you're going to have exactly this one is tail to head, tail to head, tail to head, tail to head. Then you have tail to head, tail to head, tail to head. So which means these are 7 of them. The next, they're going to be how many?
9.
Let's check. Tail to head,
10.
how many?
10.
10, well done. Tail to head, then you have tail to head, tail to head, tail to head. Then you have tail to head, tail to head, tail to head. So obviously here they're going to be 10. You can see that they're increasing by how many? They're increasing by like 3 because now the difference is 3 here, 3 there, and then here is 3, and there it's 3, and there it's 3, and there it's 3. Next. Let's look at the rectangular pattern. Okay, in the rectangular pattern, how many matches are there in the beginning?
Are there 4?
Okay, so obviously you think very carefully of that one to say, how many match are going to be there in the beginning of the rectangle? So let's look very carefully and start thinking very, very carefully. And start thinking extremely carefully of this now. Okay, and think very, very careful of the rectangular pattern and the matchsticks. Okay, so now what I'm gonna do is I'm gonna give you this one as a home activity. I'm gonna mark it in our next meeting, the rectangular pattern. Let's discuss the pentagonal pattern. Pentagonal pattern. How many matches are there in the first place? Pentagonal pattern. What does pentagonal mean? What is a pentagon? What is a pentagon?
Does a pentagon have
A pentagon would mean 5
is it
vertices.
7?
Yeah, that would be a heptagon. But the pentagon, it's 7 vertices. Pentagon is 5, that's what I'm saying. But the hept is 7. So the pentagon is 5 vertices. Okay. So how many matches are there in number 1? For the pent means 5, hept means 6, and octagon. What's octagon?
So does it have 9 vertices?
That's 8. What is a nonagon?
So,
Okay, and a
I don't know.
decagon. 10. Okay, now if you get a pentagon.
They want have 10.
Okay, let's look at the pentagon. How many are there? Matches?
Are there 5 matches?
Yeah, let's check. So you'd have this, that, this. How many here? 1, 2, 3, 4, 5. So if you look at head to tail, tail, tail to head, excuse, tail to head, tail to head, tail to head. So the number of matches are what? Are 5 first. Then, how many will they be next? How many will they be next? Yes?
Will there be 8?
Okay. Okay, let's check what they're gonna be. So you do like the same. So you grow these horizontally from any sort of side. So if you grow these horizontally from any sort of side, what do you achieve? What do you achieve? Right, so you can have this one here, this one here, this one here. Okay, I'm doing tail to head. So they're like 2 of them, these, next to each other. So how many matches are there? So we have 5, 6, 7, 8, 9. Okay. Then you continue. So this is 2, obviously. If you look at 1, like tail to head, tail to head, tail to head, tail to head, tail to head. Okay, this would be 1, and this would be 2, and then we're gonna do 3 now. 3 would be, just make the third one, the third pentagon. So you'd have tail to head, 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 tail to head,
Yeah.
tail to head, tail to head, tail to head, tail to head, tail to head. So how many are gonna be in the third one? So we counted 5,
Something.
6, 7, 8, 9, 10, 11, 12, 13. By how much are they increasing this?
By 4.
Increasing or decreasing?
Increasing.
By how much?
4.
By 4, well done. Increase just by 2, 4. All right, so yeah, look at what has happened. The numeric patterns describe, you describe that pattern. Describe the sequences in different ways. Okay, so I've given you a homework. And the homework is just to complete this rectangular pattern. We shall discuss that tomorrow, which obviously is equivalent to the square pattern. Okay, has great similarities with the square pattern. We shall discuss that in my next appearance. I must thank you for joining us. So I'm gonna see you again tomorrow.
Okay.
Right, I'm gonna see you again tomorrow. I'm planning that I see you at 4 p.m. tomorrow. I'm gonna be early tomorrow. Okay.
Okay, sir.
Yeah. So thanks a lot. Noticing that my screen had closed. Okay. Right. So I'm gonna see you again tomorrow, yeah, at 4 p.m. So we're gonna be on time to make sure that we do more things, mathematics, but more complex things, but exam preparation. That's what we're gonna be focusing on. Exam preparation, because the exam is around the corner. What date did you say again? The date?
The 13th.
13th of November.
Yes, sir.
Okay, yeah, it's knocking, it's close. You need to make sure that, so tomorrow we're gonna even do more assessments, more exam type assessments from the annual national assessments and a lot of math assessments, so that you can be sharp when it comes to solving problems in math. I'll see you tomorrow at 4 p.m. Have a good evening. Okay.
Okay, sir.
Thanks, Lin 3. Goodbye, Lin 3.
Bye, sir.
Bye.